Hello students, today we're going to look at graphing linear equations. Now up to this point we have looked at writing the equation from a table or from a graph using the slope and the y-intercept and all of those things, but sometimes we're given the equation and they want us to graph it on a coordinate plane. So we're going to do that today. And there's two different ways you can do that. The first way is you can create a table of values and then graph the table, or you can just use the slope and y-intercept. So I'm going to show you both ways for each problem, and you can pick which way you like the best. You don't have to do both ways, you just pick one which you like to do the best. So let's jump in and figure out how to do this. So the first way is to create a table of values. So it says graph the equation y equals negative 3x plus 2. So I need to create a table of values, which is an xy table, x, y. Now there are no numbers in there at all, so I have to pick some numbers to represent x, and then from that x I can figure out what y equals. So I always pick three numbers. It doesn't matter what they are, don't go crazy. I'm just going to pick 0, 1, and 2 for this problem. Excuse me. So now that I pick 0, 1, and 2, again, I pick those numbers, it doesn't matter. As long as I can graph those on the graph, they're good. So I'm going to take that 0, and I'm going to figure out what does y equal when x equals 0. And I do that by plugging the 0 in for x in the equation. So I'm going to go down here and write y equals negative 3 times 0 plus 2. Whatever these x values are, I'm going to plug them into the equation for x. Negative 3 times 0 is 0 plus 2, so y equals 2. So when x is 0, y equals 2. And now I'm going to plug in 1 in my equation. Y equals negative 3 times 1 plus 2. Negative 3 times 1 is negative 3 plus 2. And negative 3 plus 2 equals negative 1. Again, if you're not familiar or you're not confident with your negative numbers, then just use a calculator. So then when x is 1, y equals negative 1. And now I'm going to plug in 2 for x. So y equals negative 3 times 2 plus 2. So y equals negative 3 times 2 is negative 6 plus 2. So y equals negative 4. So when x is 2, y is negative 4. So now I have a table of values. I have three ordered pairs, and so I can graph those ordered pairs. 0, 2, so 0, 2 is my first. 1, negative 1, 1, negative 1, and then 2, negative 4. And those are the 3 points. And so now I'm going to use my ruler. I'm not going to play with the ruler or break it. I'm just going to use it. And I'm going to draw a line. When I draw the line, go all the way through the graph. Don't stop at those 3 points. Go all the way through. Put arrows on each end, and I'm done. I've graphed the line y equals negative 3x plus 2. That's the way we do it using a table of values. Now we can do it a different way using the slope and the y-intercept. And I'll tell you, I wrote it on the notes page. This is my favorite way to do it, is using the slope and y-intercept. Okay, so first I need to identify those. M equals, well, I look at my equation, y equals mx plus b, m equals negative 3. And because it's a slope, I want to have a fraction, so I'm going to do negative 3 over 1. Because anytime we have just a number, we can make it a fraction by putting it over 1. And now b, which is my y-intercept, is 2. Okay, so I'm going to use both of these numbers, and I'm going to use them on my graph to graph the line. The first thing I always start with, and I'm going to put an arrow here, start here, because you always have to graph your y-intercept first. So b equals 2. There's 2 on the y-axis. That's my y-intercept. Okay? And then from there, my slope is negative 3 over 1, which means I need to rise over run. So I'm going to go down 3 and to the right 1. I know it's down 3 because it's a negative number. I know it's to the right 1 because 1 is positive. So I'm going to go down 3, 1, 2, 3 to the right 1. And there's my point. And then I'm going to go down 2, 3 and to the right 1, and there's my other point. And that was so much fun. Let's do it again. I'm going to go down 2, 3, and there's my other point. And you might be thinking, well, Mr. Cohens, what if we get to a point where we can't go down anymore? What do I do? Well, then I'm going to go back to my original y-intercept, 2, and I'm going to do the opposite of these. negative 3 over 1 is exactly the same as 1 over negative 3. So I could go, sorry, that's wrong. It's not the same. It's the same as positive 3 over negative 1. I don't know what I was thinking right there. Negative 3 over 1 is the same as 3 over negative 1. So I could go up 3, because it's positive, and to the left 1. 1, 2, 3, left 1. Up 1, 2, 3, left 1. So I could either do like it is, or I could do the opposite. Either way, I'm going to get a line. Use my handy dandy ruler. Draw a line all the way through. Arrows on both ends. And I am done. So let's keep going here, and I am going to fold the page in half just so you can see what's going on. And we have another equation. And the equation is y equals 1/3 x. So I'm going to again do it both ways. I'm going to create a table of values first, and then I'll just use the y-intercept and the slope to graph it. So first of all, we're going to come up with a table of values. Now this one's going to be a little bit different because I have a fraction involved. When I have a fraction involved, I want to use numbers that are multiples of the denominator. That way I don't get fractions. So I can still use 0, but I'm going to use the numbers 3 and 6. Okay? Because 3 times 1/3 gives me a whole number, and 6 times 1/3 gives me a whole number. If I used 1 and 2, I'd get these fractions, and that's just crazy. I don't want to use fractions. So now I'm going to plug them in. So y equals 1/3 times 0, so y equals 0. So when x equals 0, then y equals 0. And so now I'm going to plug in 3 for x. Y equals 1/3 times 3, and y equals 1, because 1/3 times 3 is 1. If you don't know how to do that, use your calculator. And then I'm going to do the last one, y equals 1/3 times 6, y equals 2, because 1/3 times 6 equals 2. And so then there are my 3 points, and I can graph those 3 points. 0, 0, 3, 1, 1, 2, 3, 1, and 6, 2, 4, 5, 6, 1, 2. And there are the 3 points on my line. I draw the line, put arrows on each end, and there we go. Okay? Created a table of values. Now I'm going to do it a different way, and I'm going to use just the slope and the y-intercept. So first of all, we're going to go over here, and I'm going to identify m and b. So m is my slope, and remember it's y equals mx, whatever the number is in front of the x is a slope, so that's 1/3. That means rise 1 and run 3. And then b is whatever comes after x. Well, there's nothing after x, so what's b? Oh, yeah, you're right, it's 0. B is 0. Since there's no b there, then b has to be 0. It means it goes to the origin. And you'll look at this, and you find that it goes to the origin. Okay? So, b equals 0. Remember, that's where we start. Start here when we're graphing with the slope and the y-intercept. So we plot our y-intercept, and then I'm going to use my slope. From that y-intercept, I'm going to use my slope. 1/3. Rise over run. Because they're both positive, I'm going to go up 1, and then I'm going to go to the right 3. Up 1 to the right 3. Up 1 to the right 3. Up 1 to the right 3. And I bet you're asking, but Mr. Cohens, I can't go any farther. What if I want to write some more points? Then do the opposite. Okay? This is the same as -1 over -3. Because a negative divided by negative is a positive, I could do the opposite of both. I could go down 1 and to the left 3. Down 1 to the left 3. Down 1 to the left 3. Down 1 to the left 3. And then I have all those points on my line. You don't have to graph that many. I just kind of think it's fun. So that's what I do that. That's why I do that. So then I'm going to go right here, and I'm going to la-di-da, draw my line. Okay? Once again, you can either create a table of values, or you can use the slope and y-intercept. This way, the slope and y-intercept typically goes a little faster, but you pick whichever one you want. Now, if you will, turn the paper over to the back and do the 2 problems that are on the back before you come to Math Workshop.